I'm really excited to introduce our speaker for today, Luke Macy. So he is a current MBA student at the University of Wyoming, but he got his undergraduate degree at Arizona State University in computer systems engineering. And he is the director of sustainability. I'll probably get the term wrong, but ASUW director for sustainability. Yes, exactly. At UW right now, and it's this really amazing project that he kind of showed me at a party at the president's house, and I was like, oh my gosh, you need to present this to us so far. So I'm really excited to have him here, and I will say take the stage. Okay, welcome.
Thank you very much. I'm very grateful to be here, and I'd like to specifically thank Dr. for the invite. I think it's really special that our program allows students to speak at once. I haven't seen that in any other program, so thank you again, and I'm really excited to talk about how I've applied GIS with my background in software development. So over the last 3 years, I've always tried to bring in some type of geospatial element. I've always been drawn to really putting things on maps and then wrapping my head around the distance or maybe the magnitude and direction of like strong currents in GIS projects. There's kind of been a variety going on where, being in software, you can really relate GIS in so many different ways. And these are just a couple of the projects that really built up to the project I'm going to talk about today. And so I'm here to talk about how I apply GIS practices into a public energy monitoring tool that I've worked on since October. But before we dive in, let's kind of talk about the domino effect of how we got here. So today we'll go over the importance of energy awareness. We'll talk a little bit about how we collected consumption data and calculated emissions data. We'll do an overview of the project, and we'll talk about some of the next steps. And I really want to make this presentation interactive. So further along in the presentation, don't be afraid to pull out your laptops or your phone, because we're going to do a little bit of a scavenger hunt. So let's go back in time about 20 years ago. So I would have been around 4 or 5, and there was a mechanical engineering student that went by the name, or still goes by the name, Joey Carlson, and he saw the world a little bit differently. He was a little bit ahead of his time. He really saw that university was leaving too many lights on, and the air conditioning was on too high because it's Arizona, so it would be hot, but it could be 70 degrees and the air would be on blast. And so he noticed that there was a lot of waste going on, and he decided to form a group of engineering students, mechanical and computer engineering students, to build one of the first campus-wide public energy monitoring tools. And so they actually launched this project around 2008, and it sent a shockwave across the nation. It really started a movement of energy awareness and seeing some of the waste and improve in real time. And so that way we didn't have to wait for like monthly or yearly audit reports to see our energy consumption. We can see it in real time and how we can improve day by day. And so his project really answered the question, why is energy awareness important? It requires a lot of resources. It's incredibly expensive, not only to collect, but process electricity, coal, and gas to power and cool your buildings. And it can be wasteful at times. And so when people understand more about energy processes going on, we can hold ourselves accountable. We can hold us as individuals accountable, but we can also hold public institutions, private businesses that are accountable on how efficient their systems and practices are. And so this creates what I like to call open source sustainability, where the public can start to be more involved into energy management, and it almost gives the opportunity where public can give recommendations to facilities management on how to be more sustainable and also how to improve their own practices in the building. So things are getting more expensive, and when you go to Walmart, eggs are like $8 now, but so is coal and gas is also getting more expensive, and there's really no sign that it's going to get less expensive in the next 2 years and even past that. So since everything is getting more expensive, together combined, this is costing us millions of dollars. So in the sum cost of 2022, we spent about $10,068,000 just on utilities, and that's not including the salaries for facilities management to actually run operations using these commodities. And in 2 years, in 2024, we're projected to spend about $11 million. So we're going to increase costs by $1 million in 2 years. That's that blue line. But despite all this, operations is actually doing a good job of making our buildings more efficient. We're lowering our energy use intensity despite more buildings being added to campus. And then they're doing a very commendable job of slowly decreasing over time. But I would like to propose that if we made our consumption data public and in real time, that we could actually increase the rate of change and become more efficient faster. So there's like a million reasons why energy awareness is important. But to really jump into energy awareness, we have to start at the fundamentals. So how do we even track consumption in the first place? Well, you've probably seen electricity or water meters in gray boxes on the outside of buildings or in unfinished basements or boiler rooms. And so the university has a couple hundred meters around campus, but what we're really looking into are smart meters where we can actually have that real-time tracking. And there's really two problems with smart meters. They're really expensive. And so the university has to be strategic in where they place these meters. We actually can't afford to track everything. We can't afford to track all commodities for all buildings all at the same time. So the university placed these meters where they're specifically trying to make the building more efficient, or they're looking for a problem in particular. Sometimes, and this is very rare, they can also produce inaccurate results. Maybe during renovation of the building, someone bumped into the meter, or maybe a lightning bolt strike the building and it just lost connectivity and produce a wildly inaccurate result. That is very rare, but we have to take that into account when we're analyzing the building. And then once we collect our electricity data, we can actually calculate how much emissions that we're producing. That is through annual average emissions factors for electricity production, where we look at how much fossil fuel grid is using and coming up with a factor that we can multiply kilowatt hours by to get emissions in this class. So there's really two major accessibility problems that we're solving with a live energy monitoring tool online. The first one is that we don't have to wait for monthly or yearly audit reports, and we can actually visualize that data through any computer or any public endpoint. And kiosks are great for sustainability outreach. If freshmen or future freshmen are coming to campus, they might see that we have a live energy monitoring tool and that we're making efforts to be more sustainable. But there's one problem with kiosks. If you're looking for something in particular, and you actually want to interact with the data, then that's not possible with kiosks. You're not going to just stand there and wait 10 minutes to see something you're actually looking for, like how much water co-library consumed last month. That could take way too long. And students and faculty, they're usually in a hurry, and I'm just going to wait. And so why not give everyone access online? So who are the stakeholders? That's really going to be anyone on campus, primarily anyone on campus. So through students, we can actually use this data and apply it into our daily practices. And it'll positively impact students and faculty in particular, because we can use the data to make more projects, and we can over time see the amount of savings that we'll have. So there'll be more cost savings that we can use in other areas like food insecurity or maybe better living in the dorms. I would also argue that the local community will be positively impacted as well, because we'll be bringing up more resources like water and electricity for learning to use. And then you could even make the argument that broader society will be lowering or decreasing amount of carbon footprint. So we need more than just a public endpoint. We need more than just updating CSV online. we need a way to translate that data for people who might have a background in humanity. So to do that, we would look at how to translate kilowatt hours into something more understandable, like number of light bulbs, or number of houses, or number of gallons of gas. And so we need to translate that not only so people can actually comprehend that information, but we also need to show that, you know, there might be some missing data, like when the meters malfunction. We need to show that there might be missing data because of these inaccurate results that happen every couple of years. So we also need something that's low maintenance, something that's autonomous, secure, and inexpensive, so it's not a burden on operations. And so now I encourage you to pull out your cell phones or pull out your computer, turn into a little bit of a scavenger hunt. And and while you're doing that, I'll kind of explain what you'll find. There's going to be a couple core pages, and those are going to be, you know, your summary report over the course of 24 hours. So you'll be able to see recent energy consumption, and you'll be able to compare, you know, which buildings are consuming more energy than others. And then here's your geospatial element. And you can actually see, you know, certain buildings were placed in areas on campus because, you know, that might support the grid, because buildings that use one, they should be located close together versus buildings that don't use as much energy can be further from campus. And so when you dive into these other pages below, or pages like East Campus, West Campus, and all the individual buildings, you'll get historical data over the last few years. So that's 2019. That's kind of when most buildings are being tracked at the same time. And you'll be able to pick different commodities besides electricity, like domestic water, chilled water, hot water, and then you'll also be able to see emissions. You can manipulate the date range and the date level. You can look at the hourly, daily, monthly, and yearly use of consumption. And then below that, each area chart, you can see some useful statistics like sums, averages, standard deviations, to get a better idea on the statistics behind that area chart. And then there's a couple of radio buttons down here, like light bulbs, houses, gallons of gas, and that's the way that we're translating these statistics for people who don't have background in energy to understand. And then here's we're using box plots and histograms to really show. Okay, so here's where some of the outliers happen. So the average of West Campus is about like 2,000 kilowatt hours, but at one point, one meter showed actually 32 kilowatt hours, which is impossible. So we had to trim those outliers out and really focus on the mean. So here's a warm-up question for you. And I'll kind of walk you through this one. We'll do 3 questions. Here's the first one. Which month did Wyoming use the most electricity since the start of 2019? And so if you're on a phone, you probably want to scroll down the navigation part and say Wyoming. And then if someone is finds it, I'd be great to just blurt it out. You'll be able to get a tooltip if you're looking at that area chart. So you can scroll by and see which month.
January.
Should be.
I see.
October, yes. Okay, that was a warm question. It's all working fine, right? Everyone's ready for the next question? Okay. So this question is more about statistics below the chart. So what is half acres daily water consumption average? And this question in particular, we're looking at domestic water. So we're not looking at chilled water, we're looking at domestic water. And again, you want to look at the pie charts below to get an idea of the consumption average. And with these pie charts, you can actually compare, this building's data versus the rest of the buildings. So you can really get an idea of the relativity between the two. So answer to this one. Did anyone find it? should be 2,670 US gallons daily domestic water use. And so on this one, you would just change the commodity selector, and then you also change the date level to data, and then it should lower that value level. Last question. This one's kind of a mouthful. So this one is, what is co-library's yearly electricity consumption average estimated in the process? So this one is kind of like this 3-step question where you would go to co-library, you would change the selected electricity for electricity, and then you would go down, or you would change the date selector to yearly, and you would scroll down to the radio buttons below, and then press the radio button passes, and it should translate those pie charts into that value. This one's a little bit of a complicated one, but it's really to show off how specific you can drill down into these programs. So the answer to this one should be 5,257 houses. This question is a little bit complicated and harder even for me to wrap my head around. But if you did want to drill down and grab those specific that's good. Okay, that concludes scavenger hunt. I think it was pretty fun. But let's talk about some of the technologies used that are under the hood to build this out. Do we have any software developers in the room? So you might recognize definitely more than half these technologies. I'm sure everyone probably recognizes maybe this brings to that is too. I think the key on this slide really is that we're entirely hosted on the cloud. Don't use any physical hardware, and it's very inexpensive. It's $25 a month, so it's about your HBO Hulu bundle right there. So it's not too much of a burden. And 20 people can look at the app at the same time. But I did upgrade it a little bit because you might have more than 20 people looking at it right now. So we're going to go back to 25 on that. Then you might be wondering, how do we collect all this data? How does each reader send their data to some centralized place? And then how do we connect that to each user on the front end? And so to do that, we built a Python web scraper. That was the first step. So we got to pull in the data, convert JSONs to CSVs, and then we got to process it, remove the outliers, and then we're also creating those histograms and the box plot all at the same time. And so running this program, to get 24 hours worth of data, it takes about an hour to run. And as of right now, we have about 6.5 million new consumption records stored. And so after processing the data with our web scraper, which is hosted on a droplet in DigitalOcean, we send it to 2 places. So first, we back it up to Google Drive, which is free. You can kind of see how it's a little bit of a Frankenstein project, and we really try to use strategies to save as much money as possible. And then we also sent it to our custom PostgreSQL database, and that is hosted on Program. And so this is kind of the path where we make those custom queries, and you can really get those custom statistics and those area charts on each individual building. And using SQL, you really get those statistics at like a lightning fast speed. But on the other hand, there's also a different path. So we're using Tableau on those core pages. And Tableau is incredibly useful because I didn't have to code those dashboards from scratch. It saves a lot of time. And if you use Tableau Public, you actually get a free refresh once a day. So if you go with the Tableau Public route, it's actually free, which was very nice and cost efficient. So once you get that data refresh request, your data is updated once a day. It's literally so easy. You can just plug in an embedded script to your front end code, and it'll load that dashboard immediately. So, like I said, it's a little bit of a Frankenstein project. But does anyone have any specific questions about being part of this process? I could go into more detail, but I thought that the data flow diagram. So this is the user retention question. Why would you ever need to see this again? It might be designed to show you something that you might not have seen before, but why would you ever need to look at it ever again? And I would like to propose again that any student can use this in their own research. And I'll give you an example. With my background being in ASUW government, I could use the data in Campus Heartbeat to develop a resolution to display the importance of energy awareness and also to support the idea of getting more funding and more personnel in operations, because that way we can become a more sustainable campus over time, and they would receive some help. So, along with developing a resolution in ASUW, this project has really been incubating in a lot of student-driven sustainability-minded clubs. And the next step is really to start involving more faculty-led departments. And so I'm really thankful that the School of Computing has jumped on this project, and we'll be working not only to expand the app with predictive analytics, but we'll also be developing machine learning algorithms to pinpoint efficiencies on campus. And I will be receiving guidance from my mentor, Dr. Gong, who's here with us today, who will be helping me developing these algorithms and navigating this process of improving the app. And so I also received a couple of recommendations on collaborating with the School of Energy Resources on how we can develop more research on our carbon footprint. And I think the key here is fostering a positive relationship with UW operations. I mean, they have so much work to do, they're so busy, and becoming kind of like an open source sustainability campus is pretty ambitious. And I think that if we do foster that relationship, over time, we can really start to see how energy efficient will become. So overall, this project is really to support education, research, to help operations, and for sustainability outreach. And I think it would be a really cool project for the rest of the state to see, because it not only shows that we're leading the state in transparency, but also sustainability. So that concludes my presentation. Does anyone have any questions? I can go back and explain a little bit more about the process or anything specific.
Got a real small one. Start. Yeah, how much was the upgrade to get it over 20 people?
So Heroku, it was on a basic pricing plan and then up to a standard 0. And it went from 20 people to 120 people. And the cost went from $25 a month to about $84. So it was a pretty big jump. And that was like the smallest step that I could upgrade it. But I really think that, outside of forms like these, they'll probably only be around like less than 20 people at a time. So just for forms and introducing the project clubs, it actually broke during a time when I was presenting at Student Senate because I didn't upgrade it. I didn't realize that it might have no fault. So yeah, so we can scale up and scale back down when we need to, which is really nice. Yeah. And so ASUW would allocate funding for a full year to host the project. So we're really looking forward to keeping the project up and helping students in the future. And I think it would just be amazing to see other students using the project years after I graduate. That would be absolutely special. Anyone else?
I was just curious, when you're processing that data, what are some of the methods used to like identify outliers?
So I just used standard trimming, looking at the different quantiles, and if it was above a certain percentile below a certain percentile, that would kind of show how it's a typical outlier. And if you're interested, I can show you the script that I used in particular to capture those outliers. And so you might notice that on some of the area charts, it's a null value instead of a 0 value. So when we did find these outliers, I just turned it into a null value. And so there might be some really big dips in speed in the area charts. And if you actually look at maybe the day level or the hour day level, there might be some missing data. And that's kind of where we showed on Instagram, with outliers, that might line up with what we're doing. And then on our back page, I go a little bit more detail on why we remove those outliers. And something that might be a little bit ambiguous too, that I wanted to touch on is those are equivalent values. So when you're translating, kilowatt hours into number of light bulbs, number of houses, number of gallons of gas, and you ask like a room of GIS students or a room of engineers, they might all come up with a different answer. And really that's because you have to make certain assumptions, right? So the way we went about this was to use common values. So like for kilowatt hours to the light bulb calculation, I just used the most common value of like a 60 watt incandescent bulb, something that is really common that people comprehend that don't have backgrounds in machines.
So how can the core library is equivalent to 5,000 hours?
So that's a great question. And that was also part of this equivalent value. So when you're thinking about it, there's 4 different commodities, and then there's 3 ways to translate it. So there's 12 different calculations going on. And I actually didn't memorize that specific calculation, but you look at how much gallons of water that houses are using on average. And you can come up with a factor to multiply that out and calculate that. And also on the back page, I go and show the source.
Breath.
What mentioned is how often are you pulling the data? Like what's the data frequency? And then what's the format for the data that gets pulled from the meters, et cetera?
It's a great question. So because of Tableau Public only updating once a day, we do pull only once a day. And it takes an hour to actually back it up to Google Drive. So it's a lot of time. If we didn't use Google Drive, we could probably grab it every 15 minutes. And different campuses use different meters. So for example, at UC Berkeley, their meters update every 15 minutes. Ours in particular update every hour. And so that when we're grabbing that data, it comes in a JSON format, and then we convert that to CSV. And so that way, Tableau can access it. And then also in case we do publicly share the data sets, any student can use that data since it's in the CSV format and JSON is common for like Excel.
I have a question for you. So you have or knowledge of anybody who may be using this in the classroom? I mean, I can see where like one of our introductory level classes could use some of this data.
Yes, I will be showing it in my class.
As even a lab or to work on. So do you know if anybody's using it yet?
I've had a couple of people actually reach out to me. Someone in Sustainability Club emailed me, and they said that they were going to use it in this discussion, and I was just like, oh my god, that's amazing. And then when I posted about the forum, a student from Montana State University reached out to me, and then another student from the University of Utah reached out to me. I'm like, oh my gosh, you probably are starting to go outside of just Wyoming. Other campuses are really starting to take note of how we're say that looking for in a similar way. So no, that just made my heart go harder.
And I have one more question.
Yeah.
Thinking about the sustainability of keeping it going. Are there sources of funding that you're thinking about working with your advisor that can sort of help? I don't know, NSF funding or something that can sort of help it's going for a certain number of years and then maybe the institution can take it over as a part of everyday, facilities operation. That's probably the idea, right? Is to make it a part of a system that the campus uses going forward or something like it.
Like a long lasting tool in the future. And that's where I'm very thankful for school computing because they awarded the project grant and I'm super happy to be expanding this project with Dr. Gong and that will definitely go over the course in the summer. So if you do look at the project in the future, you might see a couple updates and there'll be projections on the graphs instead of just only live data. There might be, guesses into the future if we are becoming more sustainable over time. And so I think Dr. Gong and I will make these improvements and see if we can keep going in years into the future and really fine tuning these machine learning algorithms. Of course, make it open source so any other campus can learn ways to make their building.
We have a question online. Someone asked, does UW use digital or paper programs at graduation? And then they say, if we use paper, is there any push to have a digital one, perhaps with a QR code posted around the entrances and seats for the audience?
That's a great idea. I'm a little bit new to this campus. I'm sure we do paper still. I think that's a great question. I think implementing QR codes and going digital are always more sustainable. And I think, even in campuses like at ASU, we actually did most of our tests digitally. There was very rare professors that are handing out paper. That was really rare. And so I think that's a great idea. I'm not sure if we currently do that, but I think that's definitely a recommendation we can make to the university. I think QR code is very useful. Questions?
Yeah, I have a question about your CO2 data. How does that calculate it roughly?
So, I can, it's right here, yeah. So we use electricity reduction, and there's actually a couple of different methods that you can calculate the CO2. But really, it was looking at the amount of fossil fuel that we're using, coming up with a number that we can multiply kilowatt hour by get emissions in pounds. But there are different methods to do that. So I can actually share a paper with you that really goes into about how UW operations calculates greenhouse gas emissions. Interesting.
Another, those are all like through
So the comments,
comment.
yeah, from when they were doing the QR code stuff.
Anybody else have any more questions for Luke?
Yeah, back to when you were talking about the smart meters. Give a little more, can you expand on like how, because maybe you don't know the civil engineering behind it, but like how do they calibrate the building to reduce emissions? Like you showed at the beginning graphs of our like per square foot, we've been using less energy, but is that because of kind of physical design or is that because of sort of calibration?
It's more of a calibration. They run simulations and they start at a baseline. They simulate, if changing certain energy consumption parameters, maybe by certain levels in buildings or by certain rooms. They run these simulations and that's how they improve over time. It's really, it's a calibration. I don't know exactly how they run these simulations, but I know that they're constantly working on ways to see certain methods that they can use to become more efficient over time. So yeah, when they put these smart meters in, it would make sense that why running these simulations see that improvement over time. But yes, I think and that was sort of my proposal is that if we make that data public, anyone could run their own type of simulations, come up with their own algorithms and methods, and compare it against our enterprise manager and see if they can beat that system.
Yeah, and I was also wondering if like the meters could be removable too, so like it'd be a process, multiple year process of calibrating a building and then you. Maybe move that near somewhere else, right? I don't know how expensive they are, like, I guess, what's the ballpark?
I'm not sure either. My guess would be around like 15,000 maybe. That's a pure guess though. I've searched that after, but they do strategically place them, in certain buildings. They are constantly like moving around. That's why we see that there's missing data in certain areas. And that's because they might be intentionally trying to make a building more efficient, or they're looking for a specific problem. So it'd be amazing if we could track everything for every building. Other campuses do this, like ASUW, that one.
What's next for you?
What's next for me? Well, I'm gonna be finishing up my MBA program. I'll be graduating in May, and then in the summer, I'll be working with Dr. John. I'll still be in Larry and working on the project. So I'm really happy to present you all. Thank you so much for the ideas and brainstorming on the
Just remind people they're actually going to be another Geospatial forum after spring break, so it'll come at you faster than you're ready for it, probably won't be for the students like the evening. And that's going to be Dan McCoy, and he's going to talk about machine learning and experience. Thanks for coming today. Thanks.
Thank you, everyone.